Hello students, welcome to Umadevi Children Academy. Today we are discussing the topic is modern periodic tables. So modern periodic law and the present form of periodic tables. So when the Mendelists developed the periodic table, at that time the scientists did not know about the internal structure of atoms. It means it means the atom which contain proton, neutron inside part of the atom and the around in which electrons are rotated. The scientists did not know about this thing, or scientists did not know about the proton, electrons, and neutron. But in the 20th century, in the 20th century, the scientists know about the subatomic particle which are present in the atoms. Students. So, so in the year of 1913, the English physicist the Henry Moseley has observed the regularity of the X-ray spectra of element. He plotted a kind of graph that is the against frequency against the atomic number, and he give the relation the something the relation is there, the frequency and the atomic number, right? And the atomic number is more fundamental property of the element than atomic mass. So atomic number is the more fundamental property, most important property of the element as compared to the atomic mass that explained by the Moseley. So that's why he conducted a kind of experiment. Look at here students. So here the experiments, you have to observe here the experiment. So here in the he's passing the high voltage of alpha ray, that is the high voltage of alpha ray toward the metal. This is the metal students, right? Metal. Then the alpha ray has stuck to the this metal, it emitting the X-rays. Look at here students, these are emitting the X-rays are emitting here X-ray, right? X-ray. This X-ray, this X-ray again, na? This X-ray here, this X-ray again he passed the through the uh, through the lead through the metal crystalline solid through a metal plate, through a fine hole of the metal plate. Then the metal, these metals are emitting the different frequency. They're emitting the different frequency. Different metals are emitting the different type of frequency. Right students? Like that of the different person having the different their DNA, different their fingerprint. Like that he explained that the different when the X-ray has passed toward the crystal of the solid, crystalline solid, then these are emitting the different frequency of the light. Right students? These are emitting the different frequency of light, like this. The some metal emitting the short small frequency, some emitting the little bit longer frequency, some the very large frequency of the radiations are emitted, right? So the he concluded that the frequency, this is the frequency, this frequency is depend upon the atomic number. This frequency depend upon the atomic number. So when the X-ray, the ray of light, the X-ray light pass into the metal, the electrons are which are jump into the different energy level. Already we are discussing the last topic using the that theory. So the atom in which when X-ray has fall down, these are emitting the different frequency of radiations are emitted, different frequency, right? A shorter frequency and it is a longer frequency. Shorter frequency we called as a K shell, longer frequency we called as the L shell, again longer frequency we called as the M, like that he distinguished. Right students? So and he plotted the graph here students. Have seen that here the phosphorus, calcium, magnesium, zinc and bromine, zirconium, some metals mentioned here students. So he plotted the graph like this, the atomic numbers versus frequency. Here the frequency in x-axis, frequency in the y-axis, that is atomic number. Right students? So he put the graph, when he put the graph, the each atomic number which are giving the fixed frequency. For example, the phosphorus which are giving the fixed frequency, calcium is giving the fixed frequency, zinc, which are giving the fixed frequency. So they are connected with each other. So that's why he said that the fundamental property of the element which are depend upon the atomic number, not a atomic mass. Right, students? Based on this graph, he arranged the element in a systematic order. He organized the element in a systematic order. When okay, whatever the graph is there, now students, the frequency of the graph directly proportional to the atomic number. Z is the atomic number. Z is the atomic number. Right, students? And the frequency is proportional to the Z and Z minus B. Z minus B. So here the mu is the frequency, Z is the atomic number, B. What is B, students? B is the different element which are emitting the different type of frequency, and they having the different type of the screening and the shielding effect. So that screening and shielding effects that is indicated by the this B. Right, students? So proportional quantity taken as A, then Z minus B. So he find out like this. He conduct the experiment between the 38 to 40 elements. He experiment conductor from 38 from 1 to 38 or 1 to 40 elements. He conduct the experiment from the aluminum to gold. He conduct the experiment between the aluminum to gold, and he said that different element having the discrete spectral lines. It means each specific element which are giving the specific spectral line. This is the first point, right? And the and having the characteristics X-ray. What are the elements are there? They are exhibiting the when the alpha ray struck to the metal, which are exhibiting the characteristics X-ray. Right. We'll get students. B means screening effect, screening constant. The internal element with the which is struck which with the internal inner electrons repels to the outer electron, that is screening effect. So here what are the B I mentioned here now? This B, students, this B is the screening effect. Right, students? Here, students, here the atomic number is nothing but a nuclear charge. Atomic number is equal to the nuclear charge. Already we have discussed. Atomic number is Z. Nuclear charge we are denoted by this Z plus. Sorry, Z is square. Z is square. Right, students? So here, so if we are arrange the element on the basis of the atomic number, so it is easy to visualize the significance of quantum number and electronic configuration in periodic periodicity of the element. If you are arranged, then we have to easily find out the it easy for to understand the significance of quantum number as well as the electronic configurations. So what are the long form of periodic tables are there? Long form periodic tables, the widely used, the horizontal we called as a horizontally called as a row. Mendel is horizontal arrange the element called as a row, and vertical is called as a groups. Same thing here also, the Henry Moseley using the outer electronic configuration in the atom, arrange the vertical columns referred as a groups. Vertical columns, what are the arranged? They are called as a groups, or you will say family, same family according to the IUPAC, right? The groups are numbered 1 to 18. What are the groups are there here? The horizontal groups. The groups are, how many groups he made? He made 1 to 18 groups. It means 1 to 18 vertical columns he made. 18. Right, students? And the first A, the groups he denoted as a first A to seventh A, or you may say first B to 7th B, and 0. The all together the 7 periods, and he given as a 7 periods, right? He is given as the 7 periods and the 1 to 18 groups. Look at here, students. The groups 1 to 18 group he made here, 1 to 18, right? And that groups he mentioned as a name, first A, for second A, third B, like this, right? Okay. So here what are the groups are there? These elements, the first group of the element which are exhibit every fixed interval, they are repeating the same property. So when you are the first group contain only two elements, hydrogen and lithium. and the second groups which contain the 8 elements, right? He made this table, students. You have to see in your NCERT textbooks. So all together the 7 periods are there here. 7 periods, students. Look at here. The 1, 2, 3, 4, 5, 6, 7. 7 periods are there here. 7 periods. Right. The periods to the highest principal quantum number, and the highest principal quantum number of the element. The first period which contain the 2 elements. The first period which contain only 2 elements, hydrogen and helium. Yes, students. Hydrogen and helium which are belongs to the first period. The subsequent the contain 2, 18, 18, 8, 8, 18, 18, 32 elements respectively, right? The 7th period is the incomplete, like the 6th period. They have the theoretical maximum 32 elements. Look at here, students. The first period which contain only two elements. The second 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Second period contain 8 elements. Next 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Third also contain 8 elements. Next the fourth period 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 elements, right? 18 elements. And here also 18 elements. This fifth period also 18 elements. But here the sixth period which contain the 32. How 32? The 1, 2, 3. In this lanthanide which contains some element here, the 14 elements are present here already, right? 14 element 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 14, right? So 1, 2, 3, 3 plus, sorry, 1, 2, the 14 plus 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and this is line 30 is the 32. So 32 elements, students. 32. Here are the 32, and this is also 32 elements are present here, right, students? So he explained that the first element with the first group which contain the first period which contain 2 elements, second period which contain 8 element, third period which contain the 8 element, fourth period which contain the 18 element, fifth period which contain the 18 elements. But the sixth element which contain the 32 elements, seventh also contain 32 elements present. So here some undiscovered elements are present here. The undiscovered elements were present here. He kept here empty space, here empty space, right, students? So in this form the periodic table, the 14 elements, the both in the 6th and 7th period, the 14 elements are present in the 6th and 7th period, because in this whatever the lanthanide is there, the lanthanide anyway the same, the lanthanide is the same property. Lanthanide electrons are, lanthanide is there, lanthanide property exhibited by the same these 14 elements, right? And actinide element same property exhibited by these 14 elements. So students, the 14 elements which are present in the lanthanide of the 6th period and 14 elements which are present in the actinides of the 7th period, right, students? Okay, students, I hope you understood today's topics. If you find any doubt, then ask me, students. Thank you so much. Thank you.